Okay, for the arithmetic sequence that begins 17 plus 20 plus 23 plus 26 and so on and so on and so on, for what value of n will the partial sum Sn exceed 678? And this is a calculator question because it does get quite messy towards the end, but certainly the beginning is all the same techniques that you've been using before. So firstly, the arithmetic sequence, or an arithmetic series, you need to know U1 and you need to know D. So U1, first term, 17. D, common difference, plus 3, plus 3, plus 3. D is 3. For what value of n will the partial sum exceed 678? So n is the thing we're going to have to find, or we're going to have to find a range of values for n. Anyway, so partial sum Sn, we're going to need an expression for this. So if you consult your formula sheet, so for an arithmetic series, Sn equals n over 2, 2u1 plus n minus 1 d. Okay, we know u1, we know d. We know that we need Sn to be greater than 678, and n is the variable that we're going to look to find. So we're going to set up an inequality because it says exceed. So we're looking, when is Sn great? So we're looking for Sn to be greater than 678. So we need this expression for Sn to be greater than 678. So when is n over 2? 2u1, so 2 times 17, plus n minus 1 times d3. When is that greater than 678? And because this is a calculator question, we actually don't need to do any of this sort of processing. You can, if you like, you could tidy it up a couple more lines. I'm actually just going to go straight to the calculator because it was a calculator question. Time is factored into the fact that you've been allowed technology to solve this. So doing any more analytical methods than is necessary, yes, it won't affect you in terms of the answer, but it might cost you time that you could spend better later through the paper. So we're going to, there's multiple ways to do this. You can use a solver, you could probably use like a polynomial solver, you can move the 6, 7, 8, you could use a table mode. Personally, I like to use a graphical approach. So what I am going to do is I'm going to plot the graph. So plot, so I'm going to plot x over 2, x over 2 times 2 times 17 plus x minus 1 times 3, like that, and I'm going to plot, so that's going to be line 1, and I'm going to plot line 2, which is just going to be y equals 6, 7, 8, and I'm just going to see where do they cross, and that's going to tell me the value of n that n needs to be greater than. So we go to the calculator, I'm going to go to graph, so I'm going to come down here on graph mode, and I've got two functions in there from previous bits. I'm going to get rid of those, delete formula and delete the other one too. So the first one is x over 2. Open the bracket, 2 times 17, or 2 bracket 17, plus, in brackets, x minus 1, close the bracket, and times 3. That got the right amount of brackets, I think so. Handily on this calculator does actually color code for you. That helps you a lot. The other one is just 6, 7, 8. If I just type in 6, 7, 8, it'll give me the graph. Execute and draw. So I can see that I cannot see an intersection there, so I'm going to have to mess about with my window. So if you think vertically, well, I'm looking to see where this thing crosses 6, 7, 8. So if I don't go up to 6, 7, 8, and right now I definitely don't, it's going up to about 9, I think. So I'm going to go up to 700 in the y, and I'm going to have to guess for the x bit. So I go to view window, so F3. So my x min minus 1's okay. The max, let's try that again. So minus 1's okay, but the max, well, it's probably not going to happen after 5 terms. So let's say, I don't know, let's go up to say 50 terms or something. And then my y min, yeah, I don't mind that minus 15 so much. I mean, I could change it. I'm not that bothered. I'm going to go up to 700 here. And hopefully now I'm going to see 2 lines and I'm going to see an intersection. So execute, execute, draw. And I can see that intersection up there. So if you're worried about, oh, I'm not getting any working out marks for this, what you could do is just kind of draw the 2 lines like that and just show that you know where the intersection is. So I've got some x's around here, so something like that. And you've got the 2 lines intersection. If I show where that is, I'm going to find it now, then that will help me a lot. So I want to know where is that point, that one just there. So I'm going to go to G-solve, so shift G-solve, and I want the intersection between the 2 lines. So press F5 for intersect, and I can see that happens when x is 16.71, y is 678. So 678, 16.71. Just like that. So now that is telling me, remember, I don't have an x in the question, I have an n. So that's telling me n needs to be greater than 16.71. And if you think this is a series, or it's an arithmetic sequence, arithmetic series, n has a natural domain of, or a restricted natural domain of the positive integers. So n has to be a positive integer. It must, the next positive integer bigger than 16.71 is 17. So n must be 17. So after 17 terms, the partial sum of this series will exceed 678.